Hi everyone, we're going to verify that the intermediate value theorem applies to the indicated interval and find the value of C guaranteed by the theorem. The intermediate value theorem says if f is continuous on a closed interval, such as we have here, and k is any number between f of a and f of b, then there's at least one number C in AB such that f of C equals k. So in this case, our k is 11. And then what we're going to do is find the value of C guaranteed by the theorem. So the first thing we want to do is find f of A and f of B. So f of A, first of all, f is continuous, so on this interval, because it's just a polynomial. So we have f of 0 equals -1, and f of 5 equals 29. So we want to know if our k is in between -1 and 29. And yes, it is. So that means there's at least one number C in the closed interval such that f of C equals k. So what we're going to do is we have f of C, and we're going to set x squared plus x minus 1 equals 11. And I'm going to move this 11 over and factor, so we get x plus 4, x minus 3. So therefore we have x equals -4 and x equals 3. Now, we have to disregard x equals -4 because it's not in this closed interval here. But 3 is, so we know that f of 3 equals 11. Right? The next one, we can do the same thing. We need f of 0, we need f of 3. That's your A and B. So f of 0 equals 8, and f of 3 equals -1. So we need to know if 0 is in between -1 and 8. It is. So now we have to find this value of C that makes this k true. So we write it out, x squared minus 6x plus 8 equals 0. I'm going to factor. We get x equals 2, and we get x equals 4. This one's not in our interval, so we only have x is 2. Therefore, f of 2 equals 0. Okay, the next one we have is here. We're going to do f of 0, f of 3, f of 0 is easy. That's just going to be -2, but f of 3 is going to be 19. So, is 4 in between? This is our k. 4 is in between -2 and 19. Therefore, we're going to evaluate this at 4. We have x cubed minus x squared plus, there should only be one x here. Sorry about that. Okay, so plus x minus 2 equals 4. Move this over. Subtracted 4 from both sides. I can factor out, this is a cube. This is going to factor as x minus 2 times x squared plus x plus 3 equals 0. and the only one we're going to look for real solutions. This one has no real solutions, so we get x equals 2. Therefore, c is 2, and so f of 2 equals 4. And you can plug that in and check it out. The last one is this one. So we're going to do f of 5/2, and we're also going to do f of 4. So f of 5/2 equals 35/6, which is very close to 6. F of 4 is 20/3, which is close to 7. 20/3. So we know 6 is in between 35/6 and 20/3. This is very close to 7. This is a little less than 6. This is less than 7. So we know you can use a calculator, but you can kind of just look at that. Therefore, by the intermediate value theorem, we're going to find what my c is. So we have x squared plus x over x minus 1 equals 6. And you can cross multiply. You get, I'll put that over 1, x squared plus x equals 6 times x minus 1. X squared plus x equals 6x minus 6. Clean that up, and you're going to get x squared minus 5x plus 6 equals 0. Get x minus 2 and x minus 3. So we get x equals 2, or, whoops, x equals 2 or x equals 3. Now, x equals 2 is not in this interval because this is 2.5. So we disregard that. So we know that f of 3 equals 6. And again, you can plug the 3 in and you will get 6. Okay. Thank you. That's all. Have a nice day. Bye-bye.